Hi, this video is going to show you an example of a proof by mathematical induction. This particular question is from the Cambridge Specialist textbook for Unit 3 and 4. It's in exercise 3B, question 12A. So it's quite a typical question for proof by mathematical induction. It's what we need to do is show that 2n plus 1 squared minus 1 is divisible by 8 for all n elements of natural numbers. So what we want to do first is actually spell that out in a more precise statement that is easier to prove. So we therefore want to show that 2n plus 1 squared minus 1, we're going to put is equal to 8m. Because if something's divisible by 8, then it must be a multiple of 8. And this is how we would demonstrate that. And we will just say that m is an element of natural numbers. Okay, so the steps for mathematical induction are here, I've outlined here, and I'll go through them. So the first thing we need to do is consider the case of n equals 1. So I'm just going to take the left-hand side and substitute 1 for n. So 2 times 1 is 2, plus 1 is 3, 3 squared is 9, minus 1. So that equals 8, which we can think of as 8 times 1, which is a natural number. So therefore, it's true for n equals 1. Okay, so now the next step is to assume that it's true for n equals k. So we're just going to write what that means. So therefore, it's basically just restating this with k instead of n. So 2k plus 1 squared minus 1 is equal to 8m. So now the next step is to consider n is k plus 1, and we're going to prove that it's true for n equals k plus 1. So what that really means, we're required to prove that 2 outside of k plus 1 squared minus 1 is equal to, now I'm going to use a different letter here, I'll just say 8p, where p is a natural number, is an element of, oh, whoops, forgot the p, element of natural numbers. So now what we're going to do is rearrange this, sort of expand, simplify, and what our goal is, we want to try and tweak this around so that at some point we can find this within it and then substitute our 8m. So the first step, though, is just to sort of tidy it up a bit. So with the left-hand side is equal to, so 2k, if I'm expanding out inside these brackets, and 2 times 1 is 2, plus 1 is 3. Now I'm going to expand that again. So what we're keeping in mind here is our perfect square expansion. Remember that if we've got a plus b all squared is equal to a squared plus 2ab plus b squared. So that's going to give me 4k squared plus 12k plus 9, and then I've got my minus 1 there, and I don't really need that little bracket that I put in there. I'll get rid of it. Okay, so now, like I said before, we want to try and identify this. So that will be easier if we think about what that is if that was expanded out. So using the same thing here, I'm just going to keep in mind that 2k plus 1 all squared would be 4k squared plus 4k plus 1. Okay, so here I've got my 4k squared, so I'll keep that there, but what I'm going to do is use 4 of these. So I'm going to put plus 4k and 1 of the 9, and then I'll just add to the end what I've got left over. So obviously I've still got 8k there, and I've got 8 out of here, and I've got that minus 1 still at the end. So now we know because here we've got 4k squared plus 4k plus 1. So I know I can write that as 2k plus 1 all squared. Then I'm going to write that minus 1 next, and then I'm going to put the plus 8k plus 8. Now, here, I'll just come up over here. Now I can substitute because notice I've got that is the same as this. So I'm going to substitute in the 8m instead. So I'll say that's equal to 8m plus 8k plus 8. Now notice very conveniently we've got a common factor of 8. So I'm going to take that out and I'll have m plus k plus 1 in brackets. Now here is where we just want to realize that since m and k are both elements of natural numbers, then m plus k plus 1 will also be an element of natural numbers. So therefore, I could just say that's equal to 8p. So it's therefore true for n equals k plus 1. So for the so basically that's our proof now of mathematical induction. So we would just make a final statement that therefore by process of mathematical induction, might just abbreviate that there. We can say 2n plus 1 squared minus 1 is divisible by 8 for all n. Okay, bit squished at the end, I'm sorry, but anyway, that is the process. So that's a really common type of proof. I hope you found that helpful.